In this lesson, we're going to go over how to predict products of double displacement reactions. So first we're going to talk about what a double displacement reaction is, and then next we are going to predict products. So that means I will give you the reactants, I'll give you the left side of the arrow, and you have to predict what would be on the right side. You also need to be able to classify reactions. So if I give you a list of reactions, you should be able to tell me which ones are double displacements. Double displacements are going to have two ionic compounds that exchange ions. Two ionic compounds exchange ions to form two new ionic compounds. What this would look like. Let's say I have compound A, B, and it is reacting with compound C, D. What happens is that they are going to exchange ions. That means that the cation from the first ionic compound will bond to the anion of the second ionic compound. And then vice versa, the cation from the second is now going to bond with the anion of the first. So they're just switching ions. Let's look at an example with some real ionic compounds. Let's say I had silver nitrate plus sodium chloride. So all that happens in a double displacement reaction is the cation of the first, which is silver, is going to bond with the anion of the second. Remember, when we write ionic compounds, the cation always comes first. So now the cation of the second is going to bond with the anion of the first. So all we're doing is switching ions to make two new ionic compounds. Let's talk about how to predict products. What's going to happen is I will give you the left side of the arrow, the right side will be blank, and you need to predict those products. Step 1. Figure out the charge of all ions in the reactants. Next, the cation A will bond with the anion D. A will bond to D. The cation in position C will bond with the anion B. You're just switching ions, positive of the first, negative of the second. Lastly, when you are writing your products, they are going to be ionic compounds, and ionic compounds are neutral. So we need to figure out the ratio of ions needed to make neutral products. Ionic compounds are always neutral, so we want our products to be neutral. We need to get to that net charge of 0. First one, calcium chloride plus potassium sulfide. Again, I would give you the left side of the arrow, and you have to figure out what's on the right side. Step 1, figure out the charge of all the ions. Calcium has a charge of +2. Chlorine would be -1. Again, the charges are based on the number of valence electrons added or lost in order to follow the octet rule. Potassium would be +1. Sulfur would be -2. Next, figure out who's going to bond with who. Opposites attract. Positive of the first will go with negative of the second. Next, think about the ratio of ions needed to make a neutral compound. Well, potassium is +2, sulfur is -2, so if I have one of each, it's going to be neutral. Next, positive of my second compound, that cation will bond with the anion of the first. Again, think about the ratio needed to make a neutral compound. Potassium is +1, chlorine is -1. I'm going to need a 1-to-1 ratio. Biggest mistake I see is we want to just write left to right, and we put Cl first, followed by K. Remember, in an ionic compound, the cation always comes first, the anion comes second. Last step is to balance. I have 2 chlorines on the reactant side, so I can add a coefficient of 2 to give me 2 chlorines. Now I have 2 potassiums. I have 1 calcium on each side and 1 sulfur on each side, so this reaction is balanced. Example number 2. Let's do barium chloride plus aluminum oxide. Step 1, you need to figure out the charges. Because you need to figure out who's going to bond with who, you also need to figure out the ratio of ions needed. So step 1 always will be to write out your charges. In a double displacement, 2 ionic compounds exchange ions. Positive of the first will bond with negative of the second. Barium is +2, oxygen is -2. That would be a 1-to-1 ratio. So my formula would be BaO. Aluminum will bond with chlorine. Again, make sure the cation comes first, the anion comes second. Next, think about the ratio needed to make a neutral compound. Aluminum is +3, but chlorine is only -1. So I would need 3 chlorines to make that compound neutral. Last step is to balance. I have 2 chlorines on the left, but 3 on the right. Anytime you have an odd number on one side and an even number on the other side, make the odd one even. There's no whole number that I could multiply 2 by that's ever going to get to an odd number. Make this one even by adding a coefficient of 2. 2 times 3 gives me 6 chlorines. 3 times 2 gives me 6 chlorines. Now that I added up 3 there, I have 3 bariums, 3 bariums. That gives me 3 oxygens. Here I have 3 oxygens. And notice that our aluminums are balanced as well. 2 aluminums, 2 aluminums. Let's do one more with a polyatomic ion. Let's do potassium iodide plus lead 2 nitrate. Step 1, figure out your charges. Potassium is a group 1 metal. It's going to lose 1 electron to form a charge of positive 1. Iodine is a group 7 halogen. It has 7 valence electrons. It wants 8. It's going to gain 1. I'm going to skip lead for now. Lead can either be plus 2 or plus 4. If you don't know the charge of the cation, start with the anion. We can look up nitrate on our polyatomic ion reference sheet. It has a charge of negative 1. If I have 2 nitrates, each with a charge of negative 1, that's like a negative 2. So in order for this compound to be neutral, I know lead would have to have a charge of plus 2. Positive of the first will bond with negative of the second. Potassium is plus 1, nitrate is minus 1, 1-to-1 ratio. Positive of the second, negative of the first. Make sure we write the cation first, the anion second. Next, think about the ratio needed to make a neutral compound. Lead is plus 2, iodine is only minus 1. So I would need 2 iodines to make that neutral. Iodine isn't balanced. I have 2 iodines on the right, but only 1 over here, so I can add a 2. That gives me 2 iodines, 2 iodines. Once I added that coefficient of 2, that now changed my potassiums to 2. 2 potassiums on the left, 2 potassiums on the right. That now gives me 2 nitrates. In here I have 2 nitrates, so those are balanced. And I have 1 lead on each side, so those ones are balanced as well.